all of you present here to this international conference on science, engineering, and technological innovations to be held on dated 10th and 11th of July 2021. This conference was planned to be presented on a physical mode. However, due to this pandemic situation, it has been on an online mode rather than to be held physically in Bangkok, Thailand. Uh, to introduce our respective organizing committee, Dr. C.N. Patel, who is Chairperson of Research, Culture and Society, and Professor Natalia Morgan, who is the Head Automation, Computer Science and Technology Department of Krivire National University, Ukraine. With that, I would like to start with the first presentation session, introducing the chairperson for the presenters in today's meet. With that, I would introduce Professor Vitaly Tron, Associate Professor Automation, Computer Science and Technology Department, Krivire National University. Next, we have Dr. Pukkulari Kiran Sri, Professor, Department of CSE, Sri Vishnu Engineering College for Women, Bhimavaram, India. And next, we have Dr. V. Kavitha, Professor, PG and Research Department, Computer Application, Hindustan College of Arts and Science, Coimbatore, Tamil Nadu, India. And lastly, but not the least, we have Dr. S. Balakrishnan, Professor and Head Department of Computer Science and Business System, Sri Krishna College of Engineering and Technology, Coimbatore, Tamil Nadu, India. So with that, I would like to call upon our first presenter, who is Ravinder Singh Soumya, along with in association to Soumya Awasthi, and they're going to present a paper titled Comparative Study of Image Stenography, Steganography using a LSB, height, seek, B, PST. So the floor is all yours. You can start with this. Is he present here?
Oh, okay, ma'am. Just
Okay, you can start with the
ma'am.
presentation.
Actually, I'm not able to share my screen, so
Anyways, if you can present without the PPT,
just a second.
you try once if that is
So,
okay.
is my screen visible now?
Yeah, it's not visible. Yeah, you can start. You can proceed with your presentation.
Okay.
Just 1 minute.
Okay.
Yes. Yes, please continue.
Okay. So, good afternoon, everyone. So, we are here to discuss about the steganography, and will majorly focus on comparison of image steganography and its technique. So, let's start. So, firstly, the steganography. So the word steganography is derived from the Greek word stegnos, meaning covered or secret, and graph, meaning writing or drawing. So thus steganography is not only the art of hiding data, but also hiding the fact of transmission of secret data. So steganography hides the secret data in another file in such a way that only the recipient knows the existence of the message. So types of steganography. So firstly, we'll discuss about the text steganography, and it consists of hiding information inside the text files. So in this method, the secret files is hidden behind the every nth letter of every word of text message. So image steganography, in this is the major focus of our presentation. So hiding the data by taking the cover object as image and is referred to as image steganography. So in this, each pixel intensities are used to hide the data, and images are widely used cover source because there are number of bits present in digital representation of an image. So after that, audio steganography, the secret message is embedded into digitized audio signal, which is result slight altering of binary sequence of the corresponding audio file. And video steganography, it is a technique of hiding any data or any kind of files into digital video format. So, difference between a steganography and a cryptography. So, steganography is a cover writing, also known as cover writing, and cryptography is a secret writing. Goal is for steganography is secret communication, and for the cryptography it is data protection. And steganography is less popular, cryptography is more commonly used, and this steganography relies on the key, and cryptography has no parameters for it. So supported security principles in steganography is confidentiality and authentication. And in cryptography, it is confidentiality, data integrity, authentication, and non-repudiation. So techniques that are used is the spatial domain, transform domain, model-based, and ad hoc. And in cryptography, it is transposition, substitution, stream cipher, and block cipher. So now image technography. So as we have discussed, image technography is the process of hiding information which can be text, image, or video inside a cover image. So the secret information is hidden in a way that it is not visible to the human eyes. So now algorithms. So there are three types of algorithms in image steganography, that is LSB, least significant bit substitution, hide seek, and BPCS, bit plane complexity segmentation. So let's first discuss about LSB. So this is the most used technique using the image and sometimes the sound carrier files and is referred to as LSB. And it involves the overwriting the bit with the least arithmetic digit. Also, the result of this alters the original output negligible. So in this is an example for the LSB in which this is an image with each pixels. And from the above image, we can see that this the most significant bit and the least significant bit. So if we change the most significant bit, the change is very high, that is 99.99%. And if the least significant bit is changed, the change is very negligible, you can say. So after that, using the ASCII table, we can convert the secret message into decimal and then into binary. So this is how the LSB is done. Now the hide seek method. So this is the algorithm that distributes the text across all the images. And the name is referred after hide and seek, which is a tool in Windows 95 that works on the similar technique. So it uses a private key or password that generate a random string, and then it uses it to select the first position to hide into it. So it continues to generate the random string until the hiding message is finished, and it is not the best method, you can say, because it doesn't look at the pixels it is hiding in it. So there are two modules for this. First, creating of the Stegno medium, which contains some sort of steps, that is start the process and then enter the secret information, enter the user code, load a multimedia message. Here it is an image, and then creation of secret code by using the user code, hiding the secret information. A message showing the secret key will appear, and then stop the process. And for the extracting of image, there is a start the process, then enter your secret code, find the information, and stop the process. So after this, there is BPCS, bit plane complexity segmentation. The confidential data can be masked by digital steganography very safely by submerging them into an image called vessel data. So vessel data is also called as dummy data or a carrier cover. So in this steganography, 24-bit color images are most used dummy data. So the inbuilding operation is in practice is to switch complex areas with the bit planes of the dummy image with confidential one. So as you can see, this is a 3D representation of this algorithm. So there are the three types of bit planes, that is blue bit plane, green, and red. So this bit will be the least significant of all the three bit planes, and also the least significant in this bit plane. And this one will be the second most least significant bit for the whole representation, and this will be the third most, and these are all the most significant bit, and these will be the most significant bit in all the in the whole algorithm. Now the comparison of algorithms. So after taking these three images, we have this compare these three algorithms about how they hide the text into these images. So robustness is the first comparative. That is, robustness refers to the ability of embedded data to remain intact if the stego image undergoes some transformation. So is my video visible?
Yes, yes. Please continue.
Yes, it's visible.
Okay. So stego image undergoes transformations such as linear or non-linear filtering, sharpening or blurring, addition of random noise, rotation, and scaling, cropping or decimentation. So analysis is upon performing this steganography on all these images, we have found that the embedded data was successfully retrieved and without any loss of data. So comparison of algorithms for the another factor, that is imperceptibility. So which means invisibility of steganography algorithm. So as you can see that there you cannot see any text data file with your naked eye. So it confirms that the data is invisible by all the three steganography algorithms. So the size comparison. So from this table, we can see that upon hiding the text data into the image file, the size of the image file increases in the case of LSB and BPCS. So the size of image file decreases only the small percentage in hide-seek algorithm. So this is because the text data is saved randomly into the pixel. So that's why it's showing some small percentage. Now the histogram comparison. So here is a graphical representation for all the algorithms. So a histogram is a graphical representation of pixels exposed in your image. So the left side of the graph represent the blacks or the shadows, and the right side of the graph the highlights or the bright areas, and the middle section in midtones. So here you can see there is an image that we have taken here. Just a second. This is the image which we have performed for the histogram comparison. And there is this is the original image graph, and this is the steganography image graph. So there is no visible change from the naked eye. And in BPS, there is no visible change from the naked eye. And in hide and seek, you can see the small peak changes over here. Okay, so from these above histogram, we can see that in the case of LSB and BPCS, the distribution RGB pixels is almost the same, and hence no change is visible to the naked eye. So however, in some cases, very minute changes are visible in these algorithms. And in that case, hide-seek algorithm, the change in the RGB distribution is visible to the eye, though not very huge change, but there is a change. So since the PSNR values of the hide-seek stego image are very low, so this implies that the error in the stego image are suspectable. So the conclusion which we get is that the LSB and BPCS techniques were able to secure the data without being prone to suspectable errors, but were not able to hide data in the images with large size. So on the other hand, hide-seek technique could be embed the data into image or large size, but was prone to suspectable errors. So every algorithm has its own advantage and disadvantage, and hence the technique employed for steganography depend upon the requirement of the user. So there are a few new steganography techniques invented using these older techniques, but their type of complexity makes them very difficult to use. Thanks.
Well, that was a very nice presentation. Now it is open for question answer session. If the audience has any question to the presenter.
It's very good presentation, Ms. Saumya.
Thank you so much.
Yeah. How do you use snow steganography?
Sorry, sir?
How do you use snow steganography? Snow
Steganography.
Yeah, yes.
So actually, sir, I haven't used the snow steganography in my. I have only performed the image steganography and these three algorithms. So I don't know much about that.
Why? Because you are actually, this is a review paper only. Is it so?
It is a comparison paper, sir. So
comparisons. Yeah, yes. So in that cases, you have to make that kind of steganography also. You have to include that also. Okay.
Okay.
Okay. Then have you used S tool for making the what is that implementation part? Are you using S tool, or what kind of tool you are using for implementation?
So, sir, the tool we have used is image color summarizer. This is the tool we have used. And for that, we basically take the image for the steganographic image and the normal image and convert it into a histogram for the representation. And for that, for the conversing of the steganography image, we have used the Python programs and all in a normal CMD, so it can be converted.
Okay, well and good. And also one more thing, just you have to make it. How does the white space steganography work? That also you can include in your paper. Okay.
Okay, sir.
Then it may be get much weightage about that paper and other things. Okay.
Yeah.
Okay. Thank you.
Any more questions from the audience side? It's welcome. Okay, with that, I call upon next presenter, Harsh Jindal and Jagdeep Kaur. The paper title paper is Modification in the Design of Two-Wheeler Suspension Spring Using Finite Element Analysis and Observing Variation of Stress and Deflection with the Wiring Pitch of the Springs. So you're there. You can share your screen and start presenting. Harsh Jindal and Jagdeep Kaur. Anyone? And visible. You can start. You can start.
Okay, well, first of all, I just want to thank you to everyone for giving us the chance to present our idea or the paper. So I'm from Chandigarh University. I'm working here as assistant professor and also a research scholar in a physics department. And along with my student, the name is Harsh Jindal. So we are just going to present this paper, which the name is Modification in the Design of Two-Wheelers Suspension Spring Using a Finite Element Analysis and Observing Variation of Stress and Deflection with Varying Pitch of the Spring. So that we are going to explain today how we can reduce the stress in the vehicles by doing modifications, as I'm going to present in front of you in the following slides. So first of all, for the brief discussion, I want to present my next slide. As per the next slide, I'm just going to present the first of all the abstract, the overview, and then what is the idea, basically the basic idea, how we get this idea, and why we are just going to do modification in only in the two-wheelers by reducing the stress and varying the various pitch experimentally. So how we can came to the idea, then I'm going to explain what are the results of our idea presented, then how will it benefit a common person. So it's a very beneficial, and because as we know that as per the Indian roads, we know that how difficult for the vehicles, they just engine, the proper engine, they just properly work, and we have to work on it. So that's why we're doing the modification for the common person. So, and what type of changes is being made in the two-wheeler machine, this is the next one. And after that, how suspension spring pressure is reduced to 953 megapascal. Okay, and we are going to reduce up to 50%. Okay, I'm just going to show in the presentation. And the next part, the how the damper is used in the two-wheeler. So I'm going to explain this, and also the graphical representation between the various types of the pitch, and by varying the materials also, we are using the different materials to modify modification in the two-wheelers, pitch and the stress reduction. So, and then at the end, at the last, we are just representing the conclusion as with the materials as we are going to suggest here. So half of the past part of this presentation I'm going to present here, and rest of the part is presented by my student, the name Harsh Jindal. So now, without wasting any more time, I'm going to present next part of this, which is very important, the abstract. Basically, abstract, the overview of this main idea is that we are just doing the changes in the current methods of the calculation of the spring parameters, so which are failed to account for the role of spring pitch and by developing the stresses. So stress and the deflection are the critical factor, as we already know that, for the sustainable spring that we normally use in the two-wheelers, and play critical roles in the performance. So this paper or this invention suggests reducing the stress development by varying the pitch while proving the correlation between pitch variations and stress production. We are just going to do the experiment, and by using some softwares, I'm going to represent in the next slide the software that we're using, and how we get the conclusion, how we can reduce the 50% of this uh, uh, issue by modification. So this is accomplished by geometrical modeling of different models of spring and the simulating it with the applied boundary condition we are using. And this study is further extending to propose way to reduce the stress in the spring. Basically, we are reducing the stress by varying the pitches of different springs by changing the materials also. And finally, we just suggest the change with which we can reduce the maximum stresses in the suspension spring, as we already know that, and components by much more as 50%. Means from normally in the normal two-wheeler vehicles, we have a 1963 megapascal in the original spring that we normally use. But by our modification in this paper, by doing this, we are using double spring, inner and outer part, I'll show you, and we're reducing up to 50%, which is 958 megapascal. So this is the whole basic idea. And as we already know that journal perspective, if we're explaining the pitch is, we already know that the rotation of the vehicles about the transverse axis, and which is roll means is the rotation of the vehicle about the longitudinal axis, that we are going to change, and we reducing the stresses. Okay, and now move to the important terms that we are using in this invention. Damper we are using, suspension spring, helical, these are the key words. Helical spring, kinetic, shock absorber. So first of all, damper or shock absorber, as we already know that this is a mechanical or hydrolytic device to design to observe and damp the shock impulses that we are just rotating the wheel with the help of a spring while we are operating any mechanical machine or two-wheeler vehicle. So it converts the kinetic energy of the shock into the heat energy, which is then dissipated. So mainly this is a function of this damper or shock absorber. So mostly the shock absorber are form of the dashpot, means they resist the motion via viscous friction. So this is all about the damper definition. So what do you mean by the damper? And the next keyword that we are using here, the suspension springs, which are the link between the vehicle and the car body. So in the next figure, I'm going to show the suspension spring picture with the help of a one small animated video also, that how they are linked. And their primary test is to compensate uneven road surfaces. We know the condition of the Indian roads, and thus provide a assurance of the high levels of the ride comfort. As such, suspension springs are one of the most safely critical components of the modern vehicle. So that kind of suspension springs definition we are using here, which is also helping what we can say that if we're considering, if we explain the pitch meaning in suspension. What do you mean by the pitch meaning in suspension? Why we're using here a suspension spring? So we can explain that motion about the lateral axis is called the pitch. We already know that, and it's a measure of how far an airplane's nose is lifted up or down. We know that. And cars also experience a pitch, roll and yaw, but amounts are relatively small and usually the result of the suspension reacting to the turns, acceleration, and the road conditions. So this is very important. So now at the end, the important term that we are using here, the helical, which is the shape of the spring that we are using. Helical spring, suspension spring we are using. So these are the important terms. After that, moving to the next slide. So this is a picture, the small picture I'm just attaching here, so that the idea or the pictorial view of the suspension spring or the damper, the shock absorber, we get to know. So this is the one picture, small picture. So now in this way, in the next slide, I'm going to show here the material picture I discussed. You can see that the spring is like that. This is a spring, and which is the coil spring, you can say that, and this is a tire, which is connected with this, and this is a damper that we're using for as a shock absorber here. So moving forward, so after that, this is this type of the helical, this is the shape of the spring that we are using here to modify the two-wheeler suspension. And after moving forward, I think this, okay, so I want to show you with the help of a video, but I think it's not working here. I don't know why. So now moving forward, I'm going to explain the application of the equation, the basic idea that what kind of equation that formula we are using here to evaluate or to modify the two-wheelers, okay, and all the equation in this section we are using here the compression and the tension springs. So this is a one type of the spring, and this is this helical spring shape, and this one is T represent the torque, and this is the diameter of this spring, this one, and we are basically use this formula. H represent here the force, and which is equal to pi x r square divided by 4dx in 4d into stress. We are put all the parameter in the formula. We are just if we are taking the different types of springs, so if the one spring having the different length and different diameter, so we get to know how much force they experience by using this formula. So I'll explain you with the help of example in the next slides. So after this formula, so I'm going to introduce here the two simulation links. Okay, so these are the one of them, the simulation link, simulation software. You can say 3D modeling software, helical spring we are using. Its name is CATIA V5 we are using. So if I talk about the definition, the CATIA means the computer aided three-dimensional interactive application. So that we are using to compare the 3D imaging of this spring, and to analyze the working and efficiency by doing this modification by using this software that is widely used by the IBM and the market. Okay, so this is one of the spring that we are for the modification that we are using the one of the what we can say that software, the CATIA V5 for the 3D representation of the two-wheelers helical spring. So to explain this idea, so I'm just having one example. So in the example, suppose there is a one person having the weight 75 kg, and if the second person having the same weight, so total weight of two person is 150 kilograms, and if they both of them are seated on the bike, okay, and then the including bike, the total weight is 215 kilograms. Okay, so total weight of the bike with one person is 290 kilogram, and with this one person is this much. Okay, so assuming second weight of the act as a rear wheel, we are assuming this second one weight which is 290 kilogram as a rear wheel of the weight acts on a backward wheel. Okay, and then further continue this example to explain more. So therefore the average force acting on the rear wheel is what? One is bike plus one person. So we can multiply with this. We know that the 9.81, the gravitational force. So formula is total force acting on this rear wheel is 1406 Newton. So what we can say that if we are talking about the another example, the average force acting on the rear wheel with two person instead of one person in a one for first case. Second case, if you consider two person, so we are same applying the formula 2 into 290, the weight total weight multiplied by this, and 9.8 this acceleration due to gravity, and the total one is 1896. So we can just calculating the average force. Now you can see that the average force is for one person is that this much, and the second person is this much. So what we conclude from these two examples. Okay, so I'm explaining. So with the help of this, okay, so if I am took the dimensional simulation, okay, the first one, the CATIA V5 software. In the CATIA V software, I'm taking the two springs. One spring name is one spring one, and second is second spring. So the diameter of the first spring I'm taking here 49.2 millimeter, and D represent here the length of the spring. If I am just unwind the spring, and the total length after unwinding the spring is 7.5, and the total force on this spring is 235. H represent the force, and then again I'm using the second type of spring, but this spring having the diameter less than the first one spring, and there after unwinding the spring the total length is 6, means less than the first one, but you can see that the same type of force is acting on both of the springs. I'm just taking the first software, CATIA V5 software. With this software, I'm concluding the same force on it. And after that, so why we are using this CATIA V5? Because it gives the three-dimensional view of this, and these view we can represent by this. These are the results appear on the simulating. This is a one type of the first spring having the larger diameter. This is the second spring. So such kind of suspension or extension while force is acting, because diameter is different, length is different, but same time of force is applied. Now you can see that the extension or expansion of the spring is there in the both of the cases with the help of this software. So in this way we can see that the stress and the properties, the one that material we are using to manufacture this vehicle spring, which is the properties of the stainless steel spring. We are using stainless steel spring. Why we are using the stainless steel spring here? Because their density is very, very less. Their Young modulus is comparison to the, if I'm taking the copper as a material, aluminum as a material, and in both of the materials, they are having less density, Young modulus, and the shear strain, which is very, very lighter in weight. Okay, so after that, after comparing, after using this material, so now I'm showing you the stress analysis on the spring one with the different uh, expansions by using this software. So now moving to the next software that we're using here, which is Analysis 18.0 for representing the two-dimensional representation also. This is another software that we're using to represent the simulation part of the spring, helical spring, and these are the related figures. And after that, we come to across the data. So this is the data given by the CATIA V5's software, and this data with the help of a Analysis 18.0. Okay, I'm just wearing the pitch and I'm just using the different software. Now you can say that for the CATIA V5 maximum deflection, if I'm wearing the pitch 10.5, so the maximum deflection with CATIA V5 we observe to 128.520, and with the help of Analysis 18.0 software, we are getting 2576. So this kind of variation in the results we are observing with two software. Okay, so this is the data for single coil helical spring 2. Okay, and then which having the load that much that we are calculating earlier. So after that, how we can select? The selection criteria is same. Similarly, I'm just giving you the from the above hypothetical assumptions or analysis. I'm just giving you the two example of the spring. If I'm taking the first spring having diameter 56.7 millimeter, their length, unwinded length is 7.5, their pitch is 20, and their force acting on it is 235. And we can also consider this one, length of second type 40 millimeter, and length is that, and diameter is capital D, and pitch is 15 meter, and then same type of the force is acting on the both of the spring. That kind of conclusion we conclude from above observation by using the two softwares. And after that, we are able to propose the optimized design. So in this optimized design, we can propose the enhanced design for suspension spring. The two suspension springs we are just coaxially wind. So one suspension spring and second, and have two different diameter and pitches as I earlier suggested in the previous slide, but the same length. Hence, they can configured coaxially to make a double helical spring, one single spring. So it was supposed to have a lesser volume for the maximum stress under similar loading condition. So now it's come to verify the model of double helical spring geometry with the help of both the softwares, and we already analyzed CATIA V5 and the Analysis 18.0 parameter. And after that, this is a configuration of the proposed design, the double helical spring that we are proposed and modified. Outer spring having diameter that much, length is we are using this much, and pitch is 20, and inner we are using smaller than the outer. The 35 diameter, 35 is the diameter, length is 6, and the pitch is this one. Okay, so this kind of dimensions we are using to manufacturing the two-dimensional the helical spring, double spring helical. So this is a figure or the optimized proposed design of our helical spring. So next part of the presentation, I would like to call my student Harsh Jindal. He will explain the next part of the rest of the slides.
Yes, ma'am. Ma'am, you continue the presentation. I will just shift the slides. I will just continue with the presentation.
Okay.
This is the proposed design which we had performed on the CATIA V5 and analyzed on an NSS 18.0, and we proposed this spring to be used in the two-wheeler modification. Ma'am, next slide. And coming to the results which we had analyzed on the spring 1 and the spring 2, on spring 1, after the analysis, we came to know that we can use it as an inner spring, and the spring 2, we can use it as an outer spring. And when we both combine the springs, a helical spring was proposed, and we used stainless steel as a material of the spring because the stainless steel will not rust easily, and it can even take much stress easily. Rather, if you use copper or other aluminum material, it will just break or rust easily. Ma'am, next slide. The boundary conditions which we fixed as explained by my professor were, we fixed the load at one end to be 1406 and the other end to be 1896 Newton. Next slide, ma'am. And after that, we firstly, the reason for choosing the stainless spring was that the different densities, the least density was of the stainless steel, and Young's modulus of the stainless steel was the least. And because as we are reducing the stress, so based on shear stress modulus, we were reducing the stress. So with the least shear modulus stress in megapascal, we used the shear stress of stainless steel, which was the minimum. Ma'am, next slide. And when we calculated it on CATIA V5 and analysis 18.0, we came to know that when the load of 1406 Newton and 1896 Newton was imparted on stainless steel, the maximum deflection of the stainless steel was corresponding to what result we were expecting. So we used a stainless steel. We did not use non-alloy spring steel and oil tempered low carbon spring steel because the results were not as expected. The force or the pressure or the stress which we wanted to reduce was not reducing that much corresponding to the stainless spring. Next page. The observation which we had done on CATIA V5 and MATLAB, and we plotted all the graphs on the MATLAB, and that graphs are shown in the next slide. Ma'am, next slide, please. This graph basically shows the pitch and the pitch and the stress graph. The first graph shows that the curve is completely declining, and the second graph shows that firstly it increases and then it decreases because these are basically the two different materials. The first material is stainless steel and the next material is copper. That's why the difference is there. That's why we use the stainless steel, because it is continuously decreasing. Ma'am, next slide, please. And when the second spring we had proposed, the observation of that graph is in the next slide. Ma'am, next slide, please. This is the analysis of the graph. As first is the stainless steel, the graph is decreasing and increased a little, but it suffices the needs. Ma'am, next slide, please. The proposed design has, as already explained by my professor, that the spring one has pitch 20 millimeter and the second spring has pitch 15 millimeter. And the forces and the boundary condition we set is already explained. And the double coil helical spring is 958.20. Ma'am, can you move to the last slide?
These are the references.
And vote of thanks. Thanks to all the judges who listened for this idea. We are thankful to them. Thank you.
Thank you so much.
Thank you, Harshchandal and Jagdeep Kaur. It was a very nice presentation and a very nice quantitative inference of a study. Next, we this is open for the audience. If there is any query, any question, any comments from the audience side, it's open. So the audience can ask, comment on the presentation. So I'll move on to the next presenter, which is P.P. Kumar, P.K. Sahiti, M. Tuluri, N. Gadan, and S. Jayaraj. The paper of their title presentation is Clustering of Miniature Wind Turbines to Form an Effective Micro Renewable Energy System.
Shall I share my screen now?
Yeah, you can share your screen and start presenting.
So good evening everyone, to the respected dignitaries and professors and my friends present here in the conference. My name is Kotta Pawan Kumar. We are from NIT Calicut, and our presentation is on the topic clustering of miniature wind turbines to form an effective micro renewable energy systems, in short MRES. So these are the contents: introduction, literature review, artificial neural network analysis, frame design, computational fluid dynamics analysis, and Excel and transit based analysis, thermoeconomic analysis, results and conclusions, and references. So introduction: micro renewable energy systems are small scale energy systems that use renewable energy sources to generate power for household use. We can improve the quality of life for those who live off the grid by using these systems. They are also useful for the emergency purposes following significant power outages caused by storms and heavy rainfall, etc. MRES systems can produce enough energy required for typical households' basic needs. Literature review. Wind energy, a branch of the clean energy, as its name suggests, it's not only non-polluting but also is available in abundance. Clustering of small wind turbines has more advantages than a system consisting of single wind turbine. For example, small wind turbines have a lower operational speeds, so they can work when the wind speed is lower. And similarly, applications of artificial neural networks in wind energy systems were studied and implemented. The fluid structure interaction being complex and also due to the complex inertial movement of the turbine and is dependent on airflow around turbine and gas compressibility makes it tedious and time taking to carry out theoretical studies. Hence, numerical simulation is a better alternative along with the experimental studies. CFD is a numerical simulation method that can obtain the flow field around the turbine virtually. And also we can calculate various parameters required for estimating power output and other such quantities. Princess R has a predefined component used in renewable energy systems that can be modified accordingly to our system. For example, we can enter our power curve data of the turbine according to our system. Economic feasibility study was also conducted using thermoeconomic analysis, and results were studied. ANN analysis. We have conducted two types of analysis, namely classification analysis and time series analysis. ANN technology can map input vectors to the corresponding output vectors without assuming any fixed relationship between them. In this study, ANN is used to estimate the presence of number of turbines at a certain height. Input data given has three features, which are height, wind speed, and power, generated from turbine at that particular height. We are considering this problem as a classification problem, so outputs are 0, 1. So where 0 refers to the absence of turbine at that particular position, and 1 represents the presence of that turbine at that particular position. On running the algorithm using the following settings, we took number of hidden neurons as 10, which is a default value, and on running the network using scaled conjugate gradient backpropagation algorithm, we have obtained the following results. So these are the plots obtained: performance plot and confusion plot. Actually, the input data has 10 input points. The 10 input points consisted of 6 training points, 1 validation, and 3 test points. So in the performance plot, we can observe that the best validation performance was obtained at epoch 28. And in the confusion plot, we can see that in the test confusion matrix, all the 3 data sets were in the green square, which represents that our algorithm has worked properly and able to predict the position of the turbines accurately. ANN analysis. This is time series analysis. We tried to predict the power generation of the wind energy system. So we did it using dynamic time series tool from neural network package in MATLAB. We chose our problem as nonlinear autoregressive with external input, NARCs. We took weather data for the last 4 years or 48 months on a monthly average basis. Our inputs were wind speed, density of air, and outputs were power generated by combining all the 3 turbines. We calculated density taking pressure values of air pressure, temperature, and relative humidity. So similarly, a performance plot and regression plot were obtained. As we can see, the best training performance plot we got at epoch 23, and in the regression plot we can see that even the training test and all has an R value of greater than 0.85, which shows that the algorithm predicted the test data with an accuracy of good accuracy. There is a correlation between output and target. Frame design. Frame design is used by CATIA. We have done using CATIA. The frame design is used to support the wind turbines. There are 2 different frames which were designed to accommodate 3 and 6 turbines respectively, which are shown in figures. The figure shows the present figure shows 3 turbine configuration. As per the results obtained for 3 turbine configuration from ANN study, 2 turbines can be placed at the extreme ends on the top row of the frame, and the remaining one can be attached to the main rod of the frame just below. For the 6 turbine configuration, 3 turbines can be placed on the top row, 2 on the below row, and the remaining one can be attached to the main rod further below. The bearing, which is shown on the figure here, allows the main structure to rotate about the vertical axis, and the tail helps to coincide the direction of the wind. This is the tail. The lower part of the frame will be welded to the outer race of the bearing, and the upper part will be welded to the inner race of the bearing. CFD analysis. The CFD analysis was done in ANSYS. The flow analysis of the turbine system at different velocities was carried out in 3 different cases. The 3 cases are single turbine system, 3 turbine system, and 6 turbine system. The mathematical model used for the simulation was a realizable K model with scalable conditions. The boundary conditions given were constant velocity at inlet and constant pressure at outlet, that is 0 gauge pressure. The flow analysis was carried out for 1 turbine system at different velocities, that is 4 meter per second, 8 meter per second, 12 meter per second, and 16 meter per second respectively. And the moment was obtained, and the power was calculated with the help of the formula. Power is equals to torque into omega, or angular velocity, and the angular velocity is the angular velocity speed given to the mesh rotation, and the speeds and power obtained are tabulated in the as shown. For 0 speed, there will be no power obtained, and for the velocity 16, we got 74.9 watts. Similarly, the same analysis was done to the cluster of 3 turbine system, as shown in figure. D1 represent the central distance between the 2 turbines present on the top row, and the D2 distance represents the height between the first row and the second row. These are the configuration dimensions as tabulated. And for each analysis, the same velocities were used, the different velocities are used: 4 meter per second, 5 meter per second, and 6 meter per second. And in each case, moment was generated, and it was noted, and corresponding power generated was as shown in the table. For the distance of 2 meter interdistance, we got an average power of 32.867 watt, and for 2.25 meter, average power obtained was 32.874 watt, and for 3 meter, average power was 32.661 watt. Spatial arrangement for a 6 turbine system was made as an extended version of the 3.4 watt here, 2.25 meter. So similarly, 4 meter per second, 6 meter per second, 8 meter per second, and 10 meter per second are given as an input, and the total power obtained was tabulated as shown. Trenches and axle based analysis. With the results obtained from CFD analysis power curve, plots were plotted in Excel using different configurations of the turbine using the trend lines. Our system in Transys consisted of 4 components. They are input file, wind turbine, printer, and plotter. The system was analyzed under 2 conditions: constant wind speed and variable wind speed. An experiment was conducted to validate the system in Transys under the constant speed conditions. The experimental setup consisted of a fan, a turbine, fan stands, and other measuring equipment like multimeter and anemometer. So this is the experimental setup. We gave a power of 28 watt to the input fan, and it produces wind. There would be some losses, and the wind turbine will produce energy from the wind, kinetic energy of the input, and the kinetic energy of the remaining wind. So the velocity just before the wind turbine was 2.1 meter per second, and the kinetic energy of the remaining wind, and the velocity just after the wind turbine is 1.6 meter per second. So the difference between these kinetic energies will be collected as power. So Princes and Excel based analysis, the power output obtained from Princes are matched with the experimental results. That is, we gave an input which is constant power, and we can see a red line which is also a constant line showing in the trances. For variable wind speed conditions, we used annual weather data of Kozhikode location situated in the southwest coast of the peninsular India as an input to the system. For variable wind speed conditions, we analyzed the system in Excel and plotted the annual power output curves for different configurations of turbines with the help of trendline equations. So these are the power curves are obtained for 3 turbine configuration and 6 turbine configuration. You may observe that the trend line may not match with the series, but our power curve will be matching because our wind velocities was close to 4 meter per second. And the annual weather data is shown in the figure. Even though the wind speeds are in miles per hour, we have correspondingly converted them into meter per second and enter the data into Excel. And the right figure shows annual power output of the 3 different configurations. As we can see, the highest wind velocity is at July 2, and similarly, the highest power generated is also at the same region where the velocity is high. Thermoeconomic analysis. This analysis is being conducted to analyze the economic aspects of this project and to understand the economies of the scale in this analysis and find the best configuration from both thermal and economic aspects. This analysis is being conducted in 3 cases, namely using a single turbine, 3 turbine, and 6 turbines. Using this analysis, the best possible configuration will be estimated of the setup that could be affordable at reasonable price with better power supply. So these are the plots that are obtained: total cost versus SPB. SPB refers to simple payback period, and power versus SPB. Here the total cost includes both the material cost and the labor cost, and the simple payback period will be obtained by a formula, the total cost by the revenue generated from 1 year. So the leftmost point in both the graphs shows the system containing single turbine, and the rightmost point will show the system containing more turbines. As we can see, as the number of turbines increases, simple payback period also decreases, and the power generator also increases, and simple payback period decreases. And number of turbines versus power, as we know, as we increase the number of turbines, input velocity is constant. So more number of turbines means more power is produced. So results and conclusion. The moment obtained from the simulation using ANSYS was used to calculate power output at different velocities, and using this, the power curve data was plotted for single turbine system, 3 turbine system, and 6 turbine system. For 3 turbine system, the fan to fan distance was varied, and 3 cases were observed for the power output, and configuration correlation was obtained. In the ANN analysis, classification problem was used to identify the position of the placement of the turbines in our setup. These results were used to validate the positions taken in ANSYS analysis, and all subsequent analysis were done, such as CFD and Thermoeconomic Analysis. The data obtained from the flow analysis conducted on ANSYS were used to prepare the power curves of the 3 different sets of turbines in Transys and MS Excel. With the power data curve obtained, the weather data, it was seen that the annual power generation was follows. For 1 turbine system, it was 29.20 kilowatt hour, and for 3 turbine system, 138.1 kilowatt hour, and for 6 turbine system, 326.5 kilowatt hour. As we see, as the number of turbines are increasing, the power produced is also increasing. In thermoeconomic analysis, with the help of data obtained, the total power generated over a year was estimated, and the setup costs for all the 3 cases were individually calculated and reconfigured according to the requirements. From these calculated values, simple payback period was found for all the 3 cases, and it was seen that the 3 turbine system is more economically viable other than the 2 systems, that is single turbine system and 6 turbine system. So these were the references that were quoted, which were helpful in our literature review and our project also. So thank you for your kind attention and patience.
Thank you for this wonderful presentation on significant effect on MRES. Presentation is open for the question answer session. And if there is any comment from the audience, it's most welcome. So I move on to the next speaker. Next presenter, who is Ansal K.A. Chintu S. Raga Malika, chip pieces on Rajan. The title of the paper presentation is Design of a Novel Triple Band Microstrip Patch Antenna for KKAV band applications.
Yes, ma'am. Can I share the screen?
Yeah, please share your screen.
To present our paper on, on screen. Our paper is titled Design of Novel Triple Band Microstrip Patch Antenna for KA-B band applications, which is presented by myself, Chipi Susan Rajan, Chinchuas Ragamaliga, and Dr. Ansel K. Beginning with the overview, you can see that in with the you can see that to share these headings related to our projects from introduction, and we will walk through objectives, proposed antenna, tool use, substrate use, evolution stages of the antenna, final geometry, simulation results, applications, comparative study, conclusion, and will end with references. An antenna is a transducer that converts radio frequency fields into alternating current or vice versa. There are both receiving and transmission antennas for sending or receiving radio transmissions. They play an important role in the operation of all radio equipment. Was radio frequency fields into alternating current or vice versa. There are receiving and transmission antennas for sending or receiving radio transmissions. They play an important role in the operation of all radio equipments. We can see that microstrip antennas with rectangular and other radiators of simple geometry guarantees low profile, compact, and affordable manufacturing for real-time applications. There is a necessity for integrating the various communication devices in a single wireless gadget. Due to this, multi-band antennas are being widely used in order to cover multiple frequency bands. Here, we are presenting a novel triple-band microstrip patch antenna for K, Ka, and V-band applications. The major objectives we had in mind in designing fused antenna were designing a compact antenna by the effective miniaturization of antenna elements, integrating the modern portable wireless communication applications, designing and developing a novel and simple technique to reduce the antenna size, multi-band antenna with low profile design and with wider impedance bandwidth. Now let's see how the proposed antenna we designed turned out. The triple band microstrip antenna designed is a compact antenna with a patch and ground lying on the two sides of the substrate, operating at different frequencies and for wireless applications. We used microstrip feeding technology for providing the feed. The tool used for designing the device and FSS version 16. In here, we will discuss the substrate used for designing the triple band antenna. The tangent and the loss tangent of point of the antenna in terms of substrate size is 13 by 0.254 mm3. What you see now is the evolution stages of the antenna geometry. The triple band antenna is evolved through three major stages, which you all see now. The first stage, that is antenna 1, was a simpler geometry, which gave only the initial partial result, that is only the band of 22.9 Second index, we try to incorporate stubs to the patch to obtain the higher order frequencies. As you can see here, these are the stubs we introduced. And this indeed returned us good results of obtaining the Ka band, that is the maximum resonance at 28.3 gigahertz. The final result of the three bands, that is the K band, the Ka band, and the V band, was obtained as a result of the final geometry incorporated with 4 stubs, as you see here by the antenna 3. This is the final geometry of our antenna. To make it clear, we have separately shown in here the ground as well as the patch of the triple band antenna. Now it's time to discuss with you the simulation results of the triple band antenna. The antenna was designed using ANSYS HFSS version 16. To discuss the antenna characteristics, we took in the simulation results of various antenna parameters such as return loss, radiation pattern, VSWR, current distribution, and gain. So let's move on. In a proper definition, return loss is defined as the loss of power in the signal returned or reflected by a discontinuity in a transmission line. But what we need is always a simpler approach when it comes to practicability. That's why it is said that return loss is a quantity often used within RF circuits where impedance matching is important. The return loss is the proportion of a signal that is reflected as a result of an impedance mismatch. The plot here shows the return loss of the proposed antenna at 3 different frequencies. That is at frequencies 22.9 gigahertz, 28.3 gigahertz, and 40.1 gigahertz. From the plot, it is very much clear that at these frequencies, the resonance of the antenna is the highest, where the values being minus 16.2293 dB, minus 18.7092 dB, and minus 29.7843 dB respectively. Undoubtedly, it becomes absolute that the proposed antenna provides a higher gain for the desired band of frequencies. An antenna radiation pattern is defined as a graphical representation of the radiation properties of the antenna as a function of space coordinates. The radiation pattern is determined in the far-field region and is represented as a function of the directional coordinates. Radiation pattern provides information which describes how an antenna directs the energy it radiates, and it is determined in the far-field region. The plots given in the slide illustrates the radiation pattern of the proposed triple band multimeter antenna at frequencies 22.9, 28.3, and 40.1 gigahertz, where these frequencies must be remembered as the values with maximum return loss values we saw in the previous slide. Here, the red graph indicates the electric field of the antenna at the corresponding frequency wherein phi is 0 degree, and while the green graph indicates the magnetic field of the antenna wherein phi is 90 degrees. Obviously, the graphs tend to get more distorted as the frequencies increase throughout the analysis of the simulation results. VSWR, or voltage standing wave ratio, is the ratio of the maximum to minimum voltage on the antenna feeding line. For perfectly impedance matched antenna, the VSWR is 1:1. VSWR causes return loss or the loss of forward energy through a system. For a high gain antenna, the optimum values of VSWR at various frequencies of the sweep ranges between 1 and 2. And the given graph here, the VSWR values of the triple band, that is at frequencies 22.9, 28.3, and 40.1 gigahertz is illustrated, and the values are 2.8721, 2.0766, and 0.5634 respectively. From these values, the picture is vivid that at frequency 40.1 gigahertz, which has the highest resonance value, has a VSWR of 0.5634, which indicates that return loss and the VSWR are correlated to each other. The analysis of the current distributed throughout the antenna gives us how current flows within the antenna and the saturation levels of the current at various points within the antenna at various frequencies. Yes, that's what we try to achieve by plotting the current distributions of the antenna at the triple band frequencies, that is at 22.9 gigahertz, 28.3 gigahertz, and 40.1 gigahertz. What becomes obvious from the given plots is that the current is concentrated at a higher intensity at the vertical slots of the patch, as you can see here, the vertical slots of the patch, which also contribute towards the triple band frequencies. Antenna gain is a measure of directivity properties and the efficiency of the antenna. When the antenna has a higher gain, it does not increase the power, but the shape of the radiation field will increase the length of the distance of the propagated wave. The higher the gain, the farther the wave will travel, concentrating its output wave more. Well, let's dive into the gain plots of the proposed antenna. The analysis of the gain of triple band antenna is performed at three frequencies, as I said earlier, 22.9 gigahertz, 28.3 gigahertz, and 40.1 gigahertz. The plots from A to C indicates that the maximum gain of the antenna is obtained at the frequency 28.3 gigahertz, which is 7 dB. The other two frequencies, that is 22.9 gigahertz and 40.1 gigahertz, have gain values of 6.8 dB and 5.9 dB respectively. Next, we will discuss the applications of the triple band millimeter antenna. The primary applications of the antenna are K-band, Ka-band, and V-band applications in general. In detail, the K-band frequency of 22.9 gigahertz is an application list including satellite communications, astronomical communications, radars, high resolution and high throughput communications. The applications of the Ka-band frequency, that is 28.3 gigahertz, are satellite communications, close range targeting radars, high bandwidth communications, and high power transmission. The V-band frequency, that is a 40.1 gigahertz frequency, mainly finds its utilization in high-capacity terrestrial millimeter wave communication systems, or what we see today, the 5G systems. Here we will see a comparative study between the proposed antenna and 5 other antennas with similar functioning. From the study, it becomes clear that the proposed antenna is of 130 mm square, which is the smallest among the given set of antennas having their applications in X, K, Ka, and V band of frequencies. The novelty of our work is the compact size without compromising the desired result of applications. Thus, we could successfully achieve our objectives we set out at the beginning of designing our proposed antenna. To conclude, a novel triple band microstrip patch antenna for K, Ka, and V band applications is designed and simulated successfully by using ANSYS HFSS software version 16. It provides multiple bands of frequencies, that is 22.9 gigahertz, 28.3 gigahertz, and 40.1 gigahertz, with the corresponding return loss, as you can see in the screen. These obtained frequency bands can be successfully utilized for various microwave communications, satellite applications, and millimeter communications. The main attraction and the novelty of this work, as I said in the previous slide, is that this multimeter microstrip patch antenna is very compact compared to other existing antennas with similar applications. These were we do, and thank you.
Presenter is now open for question answer session. Any comments from the audience side?
It's a very good presentation, ma'am. For the one or
Thank
two
you so much,
questions.
sir.
Yeah. So what is
Yes,
patch in patch antenna, ma'am?
Patch is radiating portion, or we say the
Today I am here to present paper, topic a review of cryptographic techniques in smart grid. The authors are myself, Jagdishan Pandey, from Government Polytechnic Dwarhat, Almora, Uttarakhand, and Ma'am Dr. Mala Kalra from NITTR Chandigarh, India. These are the contents which I will discuss one by one. Smart grid is an advanced power grid which efficiently generates, transmits, and manages electricity. It provides two-way communication between users and suppliers. Smart meters play an important role in the smart grids. The smart meters are resource-constrained devices and are placed in the home area network to measure the electricity consumption. Smart meter measures the electricity consumption periodically and transmit the data to the utility center. The data is sensitive and prone to number of attacks such as eavesdropping, replay, and tampering attacks. To overcome these challenges, data reduction and security is required. Compared to conventional electric system, a smart grid is equipped with automated monitoring and recovery tasks along with widespread management. Smart meters collect and transmit electricity consumption data. In the smart grid, the advanced meter infrastructure AMI is continuously taking the data from the smart meters in fixed intervals. Thus, a huge amount of data is generated. Thus, to reduce the data, various data compression algorithms have been used for the smart grid. To provide the security in the smart grid, the various encryption algorithm is applied on the data. Three popular data compression algorithms used in a smart grid are run length encoding. Three popular data compression algorithms used in a smart grid are run length encoding, arithmetic coding, and Huffman coding. Where the run length encoding, it counts the number of ones and zeros in the data, and according to that number index and how many times it is being repeated in the sequence, it gives the compression. However, this method gives a low compression when the switching between zeros and ones in the data is high. Huffman coding, it uses variable length coding. The variable length coding converts the symbol into binary symbols based on the probability of occurrence of that symbol. Thus, most messages composed of repeated symbols can be compressed into a shorter bit stream. Arithmetic coding, it takes a stream of symbols and replaces them with a single number. Two main factors of any compression technique are the occurrence probability and the cumulative probabilities of a symbol sequences. The most popular encryption algorithm deployed for the smart grid are Advanced Encryption Standard, AES, Chaotic Map, Blowfish, Homomorphic Encryption, Elliptic Curve Cryptography, ECC. The AES, Chaotic Map, and Blowfish algorithms come under symmetric algorithm, whereas homomorphic encryption and ECC come under asymmetric algorithm. The symmetric algorithm structure is simple and faster as compared to asymmetric algorithm. Symmetric algorithms not provide the authentication and integrity. To achieve these properties, in the symmetric algorithms, a one-time padding key is concatenated with plain text. There is numerous ways to generate OTP keys, such as linear feedback shift register, non-linear feedback shift register, and swarm-based algorithms. However, there are several challenges of these OTP generation algorithms, such as if the initial population is not properly selected, then it falls into local optima, low convergence rate to find the optimal result, etc. Existing algorithms such as AES, Blowfish, homomorphic encryption, L-gamma encryption, etc. consume a lot of memory due to large key size and are having high time and computational complexity. This is the overview of the smart grid network. In this, it is the advanced metering. You are seeing that advanced metering infrastructure. It is an important part of the smart grid, which is comprised of smart meter, communication technologies, and technologies that control the data flow across the system. AMI allows precise usage information at reduced cost. End user get a chance to use power at lower price by having updates about market demand and pricing. AMI network infrastructure is a hierarchical network architecture that comprises of WAN wide area network joining utility center. This is the utility center to the NAN neighborhood area network, which joins the head end to the electronic meters, and house area network for joining household electronic devices to buyer's smart meter. The smart meter, there is two-way information flow between the smart meter and the utility center to transfer real-time power usage reports and relevant information such as voltage, frequency, etc. The electronic meters are susceptible to physical interference as they are located in the customer sites. A smart meter performs various tasks like recording real-time consumption, real-time cost estimation, monitoring electricity quality, detection of unauthorized access to meters, identification of power theft, and exchange of information with other electronic appliances within premises. The utility center is there and it is responsible for tasks related to the computation of bills. Literature review. Although I have studied many papers, but due to the time and space constraints, I have already discussed here only 5 papers. First one is first one is online data integrity attacks against real-time electrical market in smart grid. Published in year 2018 in IEEE transactions on smart grid. The methodology used here is the identity-based encryption. Writers are Tan et al. The proposed technology determines false data with low-cost hardware implementation, but the process of revocation of public key is very complex. Second is efficient and privacy-preserving data aggregation and dynamic billing in smart grid metering networks. Published in year 2018 in Energies. Methodology used here is privacy-preserving data aggregation scheme. The writers are Bracken, Kumar, and Martin. This proposed technology has fast data rate and reduced processing overhead, but it is vulnerable to the collusion attacks. Collusion attack is a type of attack in which the fake information is made, which is similar to the original one. So this is vulnerable to the collusion attack, this technology, this algorithm. Third one is evaluating 2 DNF formula on ciphertext. Published in year 2005 in Theory of Cryptography Conference, Springer, Berlin, Heidelberg. The methodology used here is the Bonnet, Go, Nissim crypto system. The writers are Bonnet, Go, and Nissim. This crypto system make use of LL-Gamel crypto system and ECC, elliptical curve cryptography. The difference is that in the ECC, the focus is on the prime number, selecting of the prime number, whereas in this crypto system, there is no such foundation. Only a number, a high digit number has been selected, which is hard to factorize. The proposed algorithm reduce the amount of communication and provide universally verifiable secure computation in comparison to other homomorphic encryption, but has limited support for large message. Hybrid cryptography algorithm with pre-computation for advanced metering infrastructure network. Published in year 2018, Mobile Networks and Application. The methodology is the hybrid of AES and elliptic curve cryptography. The writers are Khwaswane, Samer, and Kadoch. As ECC consume less resources as compared to RSA, so it is a less resource intensive, but it has high time complexity. Secure data obfuscation scheme to enable privacy preserving state estimation in smart grid AMI networks. Published in year 2015 in IEEE Internet of Things journal. Here also a hybrid of AES and ECC is used as for data obfuscation. The writers are Tonyali, Samet, Kakmak, Akia, Mahmood, and Guank. These proposed technology provide better good output, that is improved number of bits delivered by network per unit type time. The limitation is that it is computationally intensive and consume large number of resources. Data obfuscation is the process of replacing sensitive information with the data that looks real production information, making it useless to the malicious users. So we use here the hybrid of AES and ECC. Now the inferences drawn from literature survey. Most of the existing cryptographic approaches consume large number of resources and have high computational overhead. Diffie-Hellman algorithm is effective as far as memory, data rate, and processing overhead is concerned. However, the security depends on the key size. Larger the key size, more will be the resource utilization. Lightweight homomorphic crypto system based on lattice vector reduces computation complexity but fails to achieve protection against differential attack and several full rounds attacks using Bickley cryptanalysis. Bickley cryptanalysis is a variant of meet in the middle method of cryptanalysis, and this algorithm also have the problem of block collision if used with large amount of data. Block collision is a condition where two input blocks produce the same hash value. Lightweight message authentication scheme are effective as far as time delay and data rate is concerned. Least effort attack model has low computation complexity, however, fails to find optimal global solution. Integrity protection algorithm. This algorithm has 4 submodules. 16-bit Fletcher algorithm designed by Dr. Fletcher, which is a checksum related algorithm. Second module is permutation based encryption. Third one is checksum embedding, and fourth one is integrity verification algorithm. The proposed algorithm not only has the fast data rate but is also used in high speed data transfer, having less delay in detecting error and for integrity check. Efficient, flexible, privacy preserving data aggregation scheme has low processing overhead and fast data rate. Identity based encryption determine false data with low cost hardware implementation, but process of revocation of public keys is very complex. Usage pattern based power theft detector scheme has improved sampling rate, but privacy of customer is affected. Online sequence extreme learning machine technique provide better speed and accuracy. PICO, it is a lightweight encryption technique. It consumes lesser resources but has increased computation time due to large number of rounds as it performs permutation at bit level. So the need of the hour as far as smart grid or other resource constrained devices are concerned, we need a combination of 2 or more existing cryptographic approaches, because one single cryptographic approach cannot fulfill the needs of these type of applications which are resource constrained. So we need a hybrid lightweight approach for securing sensitive data and provide improved result in terms of memory, space, time, and computational complexity, while still providing the same level of security as provided by the best conventional cryptographic techniques like AES, Blowfish, etc., etc. So these are the references made by me, and thank you.
Yeah.
Thank you.
Yeah, screen is visible and you're audible. You can start.
Thanks to eminent speakers and session chair. I am Dr. Layouni from Badji Mokhtar University, Algeria. I'm honored to participate to this conference with my presentation. The main problem of my presentation is to present an heuristic method to estimate system performance using Markov chains process. Here we propose two approaches to describe the system. One global model called network approaches using series parallel forms. And the second is a heuristic approach based on decomposition to describe and compute measures. The second phase is to give some definition and notation about the modelization. We define availability to represent the probability that the system is capable to conducting its required function. The reliability is defined by this function. This is the probability that the component survive until some time t. Our process considering here is about two exponential case. This is very important for modelization. And all definition defined here are summarized as follows. The reliability function, this form, failure distribution function, density function of failure, failure rates, and mean time to failure, and at the end, system reliability of all the system. The methodology of approach consists to illustrate the system using the form series parallel or a parallel series. Doing the statistical analysis, computation of reliability and availability. At the end, comparing the best method. The first work consists to present the complexity of global modelization. This is based on a network approach. We consider that the system is composed by n blocks. Each block is composed by ng parallel elements as shown in figure 1. We'll assume that the reliability of element and exponential rate of failure and the rate of repair. And we will also assume that there exists two types of intervention according to failing gravity. This is very important, represented on the figure by minor repairing system and the major repairing station. The figure is presented here. This is the blocks, and this is the station of repairing element who failing. We show that there is two station min and station max. Here we assume that we propose two hypotheses. The first one is the element of block G have the same reliability, where lambda G is the failure rate of each element of block G, and xeg of life length of element E of block G. The second hypothesis is the element which fails oriented with probability equal to A toward the minor repairing station, like this. And at the end of stay in minor repairing station, the element is confronted to the following situations. The minor failure was detected and repaired. The probability of this event is denoted alpha E. The major failure is detected. In this case, the element is oriented toward major station with probability 1 moins alpha E, the duration of stay in this station is supposed exponential with parameter like this. Okay. We define the number of element block G in station minor station by this operation, and in the same of station Maj with this representation. The evolution of system is described by stochastic process. This is the stochastic process, and the state xt, this form, designed that at time t we have 1g moins xg moins yg element in block G functional, and xg plus yg is in failure into the two station. The state equation associated with network take the form below. This is the form of network process. Is defined by this equation, or this state of equation, with rate of service and rate of failure, and we define the availability with this function. The computation this of variability is given by solution given by in theory in Queening theory by Basket-Chandy-Mans-Palacio method. The advantage of this model is conform to reality. The hypothesis of exponential can be easily verified in practice, permit the distinguish the minor and major failure. Analytical resolution of the stationary is possible. The disadvantage, numerical resolution and complex implementation. We suppose to solve with Euler method, which require manipulation or manipulating a matrix. The second approach is based on heuristic to present an heuristic approach by decomposition. Now we consider that there is an identical parallel element with lambda and u respectively. The rates of fail and repair are exponential. Actions of maintenance are homogeneous and can be represented by this figure. Donc, we are to show that we are decomposed the system on to n blocks. The evolution of Markov chain described here by the diagram, by the block diagram, like this. The space state of element is represented by this equation. We make an example for two parallel elements, and we expose the state of system, and applying the Laplace transformation and inversion, we will have this possibility to solve the problem. The availability is determined by these probabilities, and the reliability is obtained by equation system where state 2 is absorbed. The reliability of system is defined on with application of transformation Laplace, this form, and the reliability of block E is given by this system, where constant S1 and S2 equal to this function or this result, who represent the result of Laplace transformation. The advantage of this model is to lead the simple model of Markov chain with three states, and the case where with the distinguished minor and major intervention, we have four states. Statistical data are easy to get, and implementation are developed. The disadvantage of the system, we suppose that the maintained action for each type of action are independent. If this hypothesis is false, the property of Markov will not be verified. It is known elsewhere that the type of organization of the maintaining is not rentable in practice. So the evolution might not become conform to the reality. They must be confirmed by validity of the numerical data, the possibility of generalization in the case of arbitrary law. The application who done here is presented by the physical model used in the process of reverse osmosis purification used in the system of healthcare. Statistical study was established and which allowed to note the following data. This is the number of failure per weeks and per month. The maximum like could estimate parameter here with Poisson law is lambda equal to 1,85, and parameters for failure and repair rate for block are established here. This is failure rate and repair rate. Results of computing the availability and reliability is done for T equal 20. The availability of blocks here, block 1, block 2, block 3, block 4, and availability of the system, global system. The reliability is given by reliability of block 1, 2, 3, 4, and the reliability of system. This is the result of algorithm. We note that it is clear that availability becomes stationary at T equal 20 when the reliability aims towards 0 at the time elapsed. We can make a comparison of this result obtaining parasteric meeting with the network exact method to compute the reliability. The solution is given by resolution the equation system of Kolmogorov. Result for the reliability after 16 iteration are given by the formula, this formula, and represented by 16 iteration. Now the following figure shows well the curve of the evolution of the reliability at time with decrease for the two methods and showed a good agreement between them. This is for network method, and this is for heuristic method. Conclusion, it is clear that the availability becomes stationary at T equal 20 when the reliability aims towards 0 when time elapses. The global method explores several number of states. If we compute the availability system, we can manipulate a matrix with dimension 28, 28, 81 by 81. And this is the case, or the low reliability and reparability are exponential. We can also use the method fictitious state of Smith. It is important to think about the method to explore solution. An heuristic method can be found, especially for our models, that is very simple to implement. This makes system very heavy and simple to modeling. We have selected the representation of system with minimal cuts based on the composition. It permits to identify the nature of failure and impacts. The evaluation and availability or reliability is performed with Markov modelization. This form of representation is initially opted for several reasons: simple statistic analysis, exponential law. We can also make a generalization to other cases. The disadvantage of this method is the explosion, the number of states in general case. This number of states make implementation very difficult because of this situation. The matrix has to be manipulated. Finally, we have to improve the numerical stability of algorithms and work to propose an extension for other statistical laws. Thank you for listening.
Thank you. That was a very wonderful presentation by Laini Sagar. So the presenter is now open for question answer session. Any comments from the audience? Yes, please start.
Okay. So this is an outline of my presentation, a brief abstract and some introduction and background, then methodology, and then I will discuss some results, and finally I will present conclusion of the results. So multi-core processors have been used in building a large number of computing devices, from large data centers such as cloud computing to small handheld devices. And in this platform, the need of writing efficient algorithms became more essential in order to achieve the expected performance and utilization of computing resources. The available algorithm called cache-aware techniques remained the most efficient during the time. But due to diverse and complex type of multi-core architecture, it became difficult, or can be said impractical, to design algorithms for each one of them. Therefore, another approach called cache-aware has attracted a growing interest of researchers for designing efficient algorithms. The present work presents a systematic study of performance and scalability of cache-oblivious matrix multiplication algorithm on multi-core platform. The experimental study was performed with different varying input sizes and processing threads. The performance bottlenecks in this algorithm has been identified, and a framework has been designed for optimization of this algorithm. And this framework designed using polyalgorithm approach, in which recursion of this algorithm was stopped at some optimized base case, and an iterative algorithm was applied as a kernel to complete the computation. And then a microkernel has been designed with the help of experimental studies, which was applied at low level for its optimization. Then this improved variant has been compared with original algorithm to evaluate the performance gain. And the
So,
okay.
Can you go directly to your design of microkernel, as you have got just 10 minutes to present your paper?
Okay. I will try to conclude within 10 minutes. Okay. Yeah. Then scalability of this improved variant has also been in introduction. It is basically during the time when computer has flat memory structure, the algorithm, the performance was measured using RAM model, in which the instructions were executed sequentially, and performance gain was increased by grading its hardware only. And then a phase of change has been observed in computer technology when this clock rate has been increased many folds, and by following the Moore's law. The speed of CPU increased at 55% and the memory increased only 10%. This has created a gap between processor speed and the memory speed. Then this model was not able to capture the performance, and then another model was designed in order to capture this overcome this limitation. That model is called cache-aware model, and the algorithm designed in cache-aware model were called cache-aware algorithms. Then this cache-aware algorithm has some limitations that designed for one machine cannot be used for other machine, although it was very fast. Then in order to overcome the limitation of this model, another model, that is ideal cache model, was designed to capture this levels of memories. And in order to overcome the limitations of this cache-aware model, and this cache-oblivious model, the idea behind is that designing algorithms without knowing the cache parameters, the complexity, and in this model, complexity was measured two parameters, that is work and cache complexity, and it was very advantageous because it was very simple, portable, and efficient. Then in multi-cores, when scientists realized that Moore's laws might not be exist due to physical limitation of processor, then the new direction has become that is called a multi-core processors, and number of cores has been extended on a single die, and that is this technology called multi-core processor. And nowadays it's a era of multi-cores, and now the different equipments are available, multi-core equipments. The efficient algorithms available for these multi-cores is no doubt cache-aware algorithms, because they know the parameters of the cache and they designed and optimized according to the parameters. But they are not portable, they are very complex, and then complexity is increasing. So the cache-able algorithms got attraction for designing these the designing algorithm for these complex hardwares. In the present work, the matrix multiplication algorithm has been considered, and the experiments were performed on this. A number of papers has been reviewed, and from the review literature it has been found that this cache-able algorithm performed well for large when the input size is very large, but it does not perform well when the size is very small. And this poor performance was due to the fact that this overhead of recursion has reduced the performance. And in multi-core environment, it has also been found that when problem size is very small, the time spent on management of thread may be more than the computation time. So these were the problems. So in order to identify these problems, some experimental study has also been performed, in which this algorithms has been experiments. A lot of experiments has been performed, and from these experiments, we have also found that the same trend that as we have found in experimental studies. So from the study, we have found that for cache-oblivious matrix multiplication remained very advantageous for large matrix sizes, but for small matrix this is not more useful. And we have also found that this iterative algorithm remained very successful for small algorithms. And also we have, when we have compared the sequential and the parallel version of small this iterative algorithm for this matrix multiplication, and the sequential remained very useful, because the management of thread has created the performance degradation. So on the basis of these issues, we have implemented this cache-able algorithm by using poly algorithm approach, in which the recursion of this cache-able matrix multiplication was stopped at some base case, and then applied this iterative algorithm for completion of computation. And we have experimentally choose this base case, and base case of 16 has been found where the performance is very good. So by using this, we have implemented this matrix multiplication, and we have found that even then this cache-able matrix multiply by implemented using this poly algorithmic approach. Even then it is less efficient as compared to cache-aware, although it remains 23% more than neighbor.
Yes, now we need to check that. Suppose recording, we need to end. That is the main thing.
Then it is experiment also performed on quad core machine, and in quad core we have also found that it's remained 45% less efficient as compared to cache aware algorithm, and it's remained more efficient as compared to iterative algorithm. Then from these experiments we have found that if we optimize base case, shifting towards sequential algorithm may improve the performance. Then the methodology we have used, these machines data set, different type of data set randomly generated, and the length of matrix is power of 2, multiple of 100, length of row we have used, that is a multiple of cache line length, then these power of 2, these are the data about. Then Intel Silk Plus platform has used been for implementation. These are the performance metrics like time, speed, efficiency. Then performance law was used, then statistical techniques like mean of experiments, then Silk View was used for the analyzing of this program. Then although our motto was not benchmarking, but we have tried to get the best results. So we have killed unnecessary processes operating systems, then turned off hybrid threading, clock speed was uncalibrated, so it turned off, and each experiment performed 35 trials, and then mean value was recorded as a performance value, performance matrix. Then what is methodology? Initially some experimental study, preliminary study, then research issues was performed, then and framework was designed, and then parallel design, and then experimental were performed analysis. And this proposed design, this fast matrix, fast microkernel was applied at cache-less algorithm with the use of this base case. Then kernel design, we have used different type of iterative algorithms as naive iterative, then tiling has been used, then iterative and SSI instructions, then transposing of second matrix has performed, and then loops was unrolled with 2 rows, 4 rows, then reordering has been done, then memory using that. Then we have then naive iterative, we have performed all these, and then the 4 best has been chosen. And from these 4 best, when we compared, we have shown that matrix has been 64, and variant of naive matrix multiplication with reordering and loop unrolling with factor 8 remained best performer for this experiment. And naive, as shown in the graph, this reordering with unrolling of 8 has performed best. Then tile matrix multiplications, all tile has been performed, and the best has been shown here. And then from this we have shown this reordering with unroll of 2 rows with factor of 2 with remained the best. Then optimized naive, and then the comparison of these naive, tile, SSE and transport has been performed. And from this,
sir, you have 1 more minute to sum up, so kindly.
Okay, ma'am, I am going to there, no problem. So this result indicate that iterative algorithm with SSE instruction and transport has performed best. Then this optimize has been applied, and then base case has been, and the results has been formed. Then this comparison of result has been formed. From these comparisons, we have found that for using this fast microkernel, we have achieved 36% performance gain by optimization and it remains 61% better than naive, and 1% it, although it performed, but even then it remained 1% behind the cache algorithm in dual core. In quad core also it achieved 29% performance gain. And then different type of input values has been performed, even then in 21% performance gain. Then a speed up has been obtained, and this speed up we have found that its value has increased, and when we have used 6 cores, then 6 workers, and it is remain ideal. And when this efficiency graph, so the efficiency remained 0.50 up to 6 cores, 6 workers, so it remains very effective, and it is ideal one. Then it has an effective framework has been designed by using poly algorithm approach, and this shall be very beneficial for designing optimized algorithm for multi-cores. This framework lays the foundation for constructing high performance algorithms in efficient manners. Then in future we can perform this approach, experiments on more number of processing cores, and can be applied to other matrix algorithms like transposition, factorization. And here we have used Intel Silic Plus framework, which automatically manage the affinity of threads. So we can also design some best strategy for that. Thank you very much. These are some references which I have.
The presenter is now open for question answer session.
Yeah, it's a very good presentation, Reyes, and concept is also very good. So why is cache used in parallel processing?
Actually, cache is a small device that is inserted between memory and the processor. So when there is a gap between memory speed and the processor speed, because processor speed is increasing 55% and the memory speed is only 10%. In order to bridge the gap, this fast cache memory is inserted in order to bridge the gaps. So when the algorithm was designed, the algorithm should, because the prefetching is done in cache and processing is very fast. So our algorithm should be able to retrieve the information from the cache. So the optimized algorithms, they knows the size of the cache, they knows the block size of the cache, and this cache aware, they are called cache aware. They knows the values of the cache, hardware of the cache. So cache aware algorithm does not knows the parameters of the cache. Even then, they performs better. So it's the benefit is that for algorithm designed for one machine can be used for all other machines without any modification. And for other algorithms, we have to modify the algorithm for every machine. So it's very useful. That's why it is portable.
Okay, what is a snooping catch?
Sorry?
Snooping catch. What it is?
Sir, I have not used.
Snooping, S-N-O-O-P-I-N, snooping catch. Have you heard
Sir,
that word?
Snooping?
Catch.
No, sir, I have not used. I'm forgetting.
Okay. Just will get the things. Okay, no problem. Okay,
Okay, no
thank you.
problem. Okay.
Thank you.
Yes, Riyaz, you need to submit your PowerPoint presentation file on the conference mail ID.
Okay. I will mail it.
Please continue with next.
So we have our last presenter for this session. That is Dr. Ajay Krishna Tiwari, and he is going to present his PPT on the paper titled "The Process and Use of Digital Technologies as a Dynamic Educational Quality Improvement." So you can share your screen and start presenting, sir.
Okay, thanks, madam. I am Dr. Ajay Kishan Tiwari. I am audible, madam. Hello.
Yeah, it's visible. It's visible.
Educational modalities which have led to the emergence of